Hello everyone, this is day 3 of our last month crash course on Advanced 2021. Let us move on to first problem. Please read through this problem and try to solve it and then look at my solution. You may pause the video. Okay guys, let us now solve the problem. I hope you have read the problem clearly. So the angular frequency is omega. Here is an inductor for which XL will be equal to omega times L. Here is a capacitor for which the reactance XC will be 1 by omega C. And here is a bulb which is like a resistance R. Now, if A is closed, that means the inductor won't function. So effectively, the circuit will be RC circuit. If A is closed, inductor won't function. Okay. The current will go from R to C, okay, and through the battery, but not through the inductor. And similarly, when B is closed, the capacitor won't function. So effectively, we have RL circuit. Okay, so here in RC circuit, the impedance, okay, let it be Z1. In the RL circuit, let it be Z2. In both cases, the resistances are R only. Okay, so power factor, that is cos phi 1, we say, is R by Z1 here, which is equal to 3 by 5. And here the power factor cos phi 2, R by Z2 is equal to 4 divided by 5. Now we can draw the impedance diagram, okay, in which case resistance will be on the real axis. The impedance of the capacitor or inductor will be along the complex axis, okay. So we can simply draw it like this. Here it is XC and you have Z1. And the angle between resistance and the impedance, that will be your phi 1. Okay, and here you have R, XL and Z2, and this is your phi 2. So phi 1 is 37 degrees, phi 1 is 53 degrees and phi 2 is 37 degrees. Okay, and now R tan phi 1 is equal to XC. So XC comes out to be 4 by 3 R, because tan 53 is 4 by 3. And since phi 2 is 37 degrees, we have R tan phi 2, which is equal to XL, that is equal to 3 by 4 R. Okay, so now the last statement we shall read carefully. We have to change, we have to scale up omega, okay, to ensure that bulb glows the same when A and B, okay, are either closed or open. So when A and B are closed, none of capacitor or inductor will function. So it will be like a pure resistor circuit. And when A and B are open, both will function. It will be RLC circuit. Now, when does RLC circuit act like a pure resistor circuit? That happens in resonance. And the angular frequency for that, omega naught, is 1 by root LC. You know that. So our omega existing, okay, how is it related to L and C? So XC, which is 1 by omega C, is 4 by 3 R. And XL, which is omega L, it is 3 by 4 R. Now, let us divide xc by xl. Okay, let us try to get xc by xl. Now that will be nothing but 1 by omega square into 1 by LC, that will be omega naught square. But that is equal to, from here, it will be 16 by 9. So we realize that omega naught is equal to omega times 4 by 3. And therefore, we have to scale the omega by 4 by 3 times in order for the resonance to happen and the circuit to behave same when A and B are both closed or open. So we have to scale up the omega by 4 by 3 times. So that is the idea. Please read this problem by pausing the video and try to solve on your own, and then I will solve the problem. So guys, here there is electron beam coming with velocity v, okay, and the number density, that is number of electrons per unit volume, is n, okay. So you can easily understand that when such a beam falls on the sphere, all the electrons which are crossing through an area of pi r square, where r is the radius of the sphere, okay, all of the electrons will fall onto the sphere. So the cross-sectional area is pi r square, okay, and number density is n, the speed is v. So the incoming current I naught is nothing but NEA into V, which is similar to our current formula in current electricity, where we write I equal to NEA BD. Just that instead of drift speed, here we have electron speed to be V. That is the only difference. So the sphere receives a constant current of NEAV or NE pi r square V. And then, unlike our regular electrical circuits, the current okay, throughout need not be same. Why? Because here there can be charge accumulation on the sphere, or the sphere, that which is a conductor, can give the charge its own charge. In addition to the electrons coming, the sphere can give its own charge and drive the current. Okay, that also can take place. Okay, so I hope you are clear so far. Now let us try to move ahead. So electrons are coming. Okay, so here when I write I naught, in fact the current is towards left, not towards right. Why? Because electrons are coming. Those are negative charges. That's why. Okay, so please try to understand that. Now let us solve this problem. Okay, now at any time let the charge be q and current from the ground, let it be I. Okay, so here we have to understand that for the sphere, the incoming current is I and outgoing current is I naught. Okay, and that is equal to dq by dt. That is equal to dq by dt. Okay, because if suppose I equal to I naught, the charge on the sphere will remain constant. Okay, now one more thing we know, that in an inductor, whenever current flows, okay, along that direction we can take a potential drop of L di by dt. Okay, so this is 0. So 0 minus L di by dt is equal to the potential of the sphere, which is nothing but q by 4 pi epsilon naught r. Okay, this also we shall not forget. I hope you are clear so far. Now let us differentiate the first equation. So we will get di by dt is equal to d square q by dt square. But from the second equation, di by dt is also minus 1 by 4 pi epsilon naught RL times Q. So now together we get an equation which I am writing on the left side. So we are getting d square Q by dt square is equal to minus 1 by 4 pi epsilon naught RL times Q. So Q here varies as a sinusoidal function, because from the chapter of SHM, you know that whenever the second differential is proportional to the quantity itself with a negative sign, that too, okay, the proportionality being negative, so it will be a sinusoidal function. So I can say Q is equal to some Q naught times sine omega t plus phi. Now at t equal to 0, the charge on the sphere is 0 initially, and therefore either phi is 0 or pi, okay, you will get. Now, what is dq by dt? dq by dt is q naught omega cos omega t plus phi, and at t equal to 0, dq by dt from here, okay, at t equal to 0, the current through inductor will be 0, because inductor does not allow abrupt change in current, and therefore initially dq by dt will be minus I naught. So dq by dt equal to minus I naught, and therefore we realize that we can take phi to be pi, not 0, and q naught omega into minus 1 is equal to I naught, or q naught into omega is equal to I naught. So we get the q naught is equal to I naught by omega, and I naught is nothing but n e pi r square into v, and omega is nothing but under root of 1 by 4 pi epsilon naught RL. If you use all these things, you will get the maximum charge Q naught on the sphere to be the first option. Okay, so that is the main idea. Okay, and then once you know the charge, okay, you can easily use that in this equation and get the maximum current through the inductor, and that happens to be option C. Okay, so you may please do that. I hope you have understood this. So in this question, you please read the question, try to solve it, okay, by pausing the video, then I will discuss. So guys, here we can actually consider the motion of one of them only, the other one is not needed. So here, if you break the spring here, there will be no problem. Okay, we can see that this part of the spring will always stay like this, and okay, the motion of this spring mass system onto the right side, okay, will be independent of that on the left side. And when you break a spring into two halves, each one will be double the spring constant. So the spring constant we have to take is 2k. And let us say the mass goes down by a distance x. Then how much restoring force we will get, okay, that will decide the frequency of oscillation. And you have to understand that frequency of oscillation can be found by taking gravity free space also, because the gravitational force, which is a constant force, will not govern the frequency. And therefore, when I take gravity free space, initially the mass is anyway in equilibrium. From equilibrium, I have let it move by a distance of x. Okay, now let me find the restoring force. Now, please keep in mind that when the body moves down by x along this incline, okay, so how much the spring will get compressed? That is our main question. So this is the vertical line. So the spring compression, okay, will be only this much. And I know that this angle is theta and this is x. So if the displacement of the block is, or the mass is, the particle is x, then the compression in the spring is x sine theta. So the force in the spring is 2kx sine theta. So on our particle, there is a pushing force by the spring, which is 2kx sine theta. And the normal reaction will also act, okay, like this, or the other way around, doesn't matter. Okay, normal to the surface of, okay, those rails. And then these are the only two forces because we are taking a gravity free space. So the normal component of spring will cancel the normal reaction. We don't have to really worry. And this angle here is 90 minus theta. So the tangential component of the spring force, which is 2kx sine theta times again cos of 90 minus theta, which is also sine theta. This is the restoring force. So we can write minus 2kx sine square theta, because the displacement is down, but the force is, restoring force is up the incline. That is equal to m into a. So the acceleration is minus 2k sine square theta divided by m into x. So our omega is square root of 2k by m sine square theta. So the frequency of oscillation, if we really need, then that will be omega by 2 pi f. Okay, that will be 1 by 2 pi root over 2k by m into sine theta. So that will be the frequency of oscillations. I hope you have understood this. So question 4, this is similar to a previous advanced question given in 2019, and I want the students to solve it on their own. I will leave this as a challenger, and in day 2 video also we need to discuss one small part in the last question. So these two things we will discuss on day 4 video, okay, that we will release little later. So I will leave this question as a challenger to the students. Please try to solve it, okay, on your own, because this is a previous IIT, similar question to a previous IIT question, okay, that was given in 2019. So just some of the things are changed, okay, little bit, but you can try it, okay, and then we will discuss it later. So we will move on to the 5th question, okay, which is a very simple question. Please read through this question and then I will discuss it. Please pause the video and read through this question. Remember units and dimensions and measurements. This particular chapter, definitely a question from there, okay, has been occurring in all the advanced examination in the last 5 years. So you have to put extra caution on this particular chapter. Okay, I will discuss this question. So let us say this is the main scale. and one fixed jaw. Okay, let us keep it that way. The other jaw will be fixed to the vernier scale, as we know. So let this be the vernier scale, and actually by vernier principle, for example, if mth division, okay, on the main scale matches with the 0th division of the vernier scale, at that time typically the nth division on the vernier scale would have matched with n plus 1, n minus 1th division from here. That means m plus n minus 1. Okay, would have matched with that. Okay, and then if the vernier further moves from here, okay, if I move the vernier slowly a bit, okay, further, in order to accommodate the object, then the 0 of the vernier will slightly be ahead of the mth division. Okay, so if our 0 of the vernier is between m and m plus 1 on the main scale, we take m as the main scale reading. And if somebody is saying the nth division matches with that of a main scale, since we have moved forward, it is obvious that, okay, n main scale divisions from there, okay, that means the m plus nth main scale division is what matches with the nth division of the vernier scale now. This is the actual principle, and that is why typically in a vernier, what they say is, you go m plus n divisions on the main scale forward, and you go n divisions on the vernier scale backward, and that will be nothing but the length of your object. The length of your object, which is accommodated between the jaws, is nothing but m plus n main scale divisions minus n vernier scale divisions. Actually, if some of you are a little confused, let me tell you, in general also we take main scale reading into main scale division plus vernier scale reading into least count. This is our regular measurement we take. But what is least count? Least count is nothing but, in a typical vernier, it is one main scale division minus one vernier scale division. So this also comes out to be m plus n main scale divisions minus n vernier scale divisions. So I hope you understand this. Okay, now let us say the main scale division is y and vernier scale division is x. So if the total reading, okay, or the total measurement, which is nothing but the length of the rod, and that is not changing with temperature because the quartz rod has no thermal expansion. So if that anyway remains constant, okay, then if our reading of the vernier calipers also should not change, okay, it means that our reading should be equal to original reading, which remains constant. So measurement also remains constant here. So actually the actual length of the quartz rod remains constant, and it is given that reading of vernier calipers should not change upon changing temperature. It means Actually speaking, whatever reading we take once, the same measurement we should get all the time, which implies that the measurement also should not change. If the measurement should not change with temperature, it is quite obvious that we can write m plus n into delta y is equal to n into delta x, because delta of measurement is 0. And therefore, the change in length of m plus n main scale divisions is equal to change in length of n vernier scale divisions. Okay, that should be the condition in order for us to have the same measurement all the time. I hope you understood this. Okay. Our next video will be live on 14th September at 3:30 p.m. We will discuss what were left in day 2 or day 3 videos. That is the discussion about last problem of day 2 or the discussion on the 4th problem in day 3. Both of them we will discuss on the video for day 4. Okay. So please subscribe to our channel to get more updates. Thank you so much.